Welcome to Spring LIB.
Let us consider a uniform rod of length L. The length is capital L. Let us consider the pivot to be here. Let it be O. And this be E, which is the geometrical center. Now the distance between the pivot and the geometrical center, let us consider it to be X. We also know that omega equal to root of mgd upon I. Now, let d be equal to x. What is x? It is the distance from the geometrical center to the pivot. So this distance, let us consider to be d. I is the moment of inertia about the axis of rotation through O. Now, by the parallel axis theorem, here we are using the parallel axis theorem here. Parallel axis theorem. What can we write is I naught equal to md square plus ICM. And we know center of mass ICM is equals to 1 by 12 ml square. Therefore, we can write I naught equal to md square. So we are writing as mx square because we have already told d and x are equal. Mx square plus ICM we have taken as this. This is 1 by 12 ml square. Why? It is center of mass. And we know omega equal to mgx upon mx square plus 1 by 12 ml square. This much is what we have. Therefore, we can write omega to be root of gx upon x square plus L square by 12. This is what we require. This is the A part. Now when we move on to the B part of it, we are moving on to the B part. The maximum omega, that is omega max, as x varies, occurs when does it occur? When d omega upon dx equal to 0. This means that root of g, d of dx, omega we have to see, x raised to half upon x square plus L square upon 12 raised to half equal to 0. This is the case. Only then will our omega be maximum. So in this case, what we are going to get is half x raised to 1 by 2 upon x square plus L square L square upon 12 raised to 1 by 2 minus half 2x upon x square plus L square upon 12 raised to 3 by 2 into x raised to 1 by 2 equal to 0. This means that x raised to minus half minus 2x raised to 3 by 2 upon x square plus L square upon 12 equal to 0. So we are taking, this is now an equation that we get. Now we have just to solve it. This means that x square plus L square upon 12 equal to 2x square. Therefore, x equal to, how do we get that? X is equals to L upon root 12. So, we get maximum omega when the pivot is at a distance of L by root 12 above the center of the rod. So, the maximum omega or the angular frequency, we get it at this place. So, when we move on to the C part, we have got B max in the above equation. Now in omega, we have omega is equals to gx upon x square plus L square upon 12. Now let us substitute x is equals to L by root 12. This is the case for omega max. Therefore, omega max when we calculate will be equal to, we have taken many commons and at last we get it. Omega max is equals to root of g upon L 3 raised to 1 by 4. This is what we get. Therefore, omega square max, this is omega max. This is g by L root 3. Therefore, L equal to g root 3 upon omega square max. From here, we can get omega, from omega max, we are getting 2 pi rad per second. It gives L equal to 9.80 meter per second square into root 3 upon 2 pi rad per second the whole square, which is equals to 0.430 meter. So this is the value for our L.